right, good morning geometry, periods 3 and 4. It's Mays once again. It's the 1st of June. This is the second video I'm going to put up today to assist you with your semester test. Just kind of marching through it. You might recognize these three problems. They're not exact, but boy, are they close. So let's give it a go. Here we go. All right, so you might have a problem on your test that looks something like this, okay? If you go to page 572, segments of secants and tangents theorem, it will tell you that given a tangent, that's that AB thing, from an exterior point, and then you've got a secant that whips through there, all right? You get some pieces, okay? Your theorem says that the tangent squared is equal to the whole thing, AD, times the piece on the outside, AE. Okay, so in our case, the tangent's equal to 24. The whole thing from A to D, segment addition postulate, x plus 12, and the length of the exterior piece, EA, 12. Okay, so if you set that up, you get 24 squared is equal to x plus 12 times 12. 576 is equal to 12x plus 144, because I know you know how to distribute. And then you're going to subtract the 144 and divide by 12, and x is equal to 36. Okay? Not a bad problem. All right? Now, let's move over to this one. You might have something on your semester test that looks like this. Well, this is the segments of chords theorem. It's found on page 570. It says, now notice that point E is not the center of the circle, not the center of the circle. Not that it really matters for this, but I'm just illustrating it's not the center of the circle, okay? Otherwise, you'd have 4 radiuses, wouldn't you? That'd be kind of silly. All right, so it's obviously not the center of the circle, okay? So this one says that the product of the parts is equal to the product of the parts, okay? So AE times EC is equal to EB times ED, okay? So now I took the time to actually label my components, label my pieces, so that I plug them in, I can see exactly what I'm doing. And if you do that, you find that x is equal to 5. Okay? And you can look at that, 6 times 10 is equal to 60. 60 divided by 12 is 5. You got one in your head. All right. And then you might have a problem that looks a little bit like this. Now, I think that your lines might actually cross over each other. So anyway, but I decided to do it like this. Now, here's something we're having a little trouble with. The equation of a circle on page 576, okay? I really wish we could have spent more time doing this because I love the algebra portion of circles. I really do. There's so much you can do with them, with midpoints that connect of different radiuses and triangles you can form. It just gets super fun. But anyway, we don't, so I will cry in silence later. Anyway, if you look at the equation, now this is centered at the origin because notice there's no h's and k's. You see that 49 on the end? That's the radius squared. So you have that one question that says, what's the equation of the great circle? Well, that's just the biggest circle you can get out of a sphere. Well, if the radius is 6 and it's centered at the origin, it would be x squared plus y squared is equal to 36. If you have this circle right here, x squared plus y squared is equal to 49, the radius is 7. It's the square root of 49. If it was x squared plus y squared is equal to 81, the radius would be 9. If it was x squared plus y squared is equal to 400, the radius would be 20. Okay? All right. So your questions read something like this. You're going to have to find something like find the length of arc AB, the area of the sector ACB, the measure of the arc EAF or EABF, and the length of arc EABF. Okay? You're going to have to find some of that stuff. All right? Now, this is a very easy problem because we know the area of a circle is equal to pi r squared, and we know the circumference is equal to pi times 2r or pi times diameter. All right? Now, if I'm going to find the length of that arc AB, I have 85-degree central angle. It's a central angle. It's circle C. Central angle is 85 degrees. I'm trying to find 85 360ths of the circumference. We got that? 85 360ths of the circumference, okay? I'm only trying to find a part of it. So let's find the circumference. Well, 14 pi. The area of the circle, pi r squared. Look at that. 49 pi. Now, I haven't multiplied these out, but you can do that. Now the length of arc AB, 85 360ths times the circumference. I'm trying to find a portion of the circumference. The area of the sector, I'm trying to find a portion of the area. I'm trying to find 85 360ths of the area. Okay? And then the measure of arc EABF. Notice it says measure. Okay, it doesn't say length, it says measure. Remember, angle EDF is an inscribed angle. The measure of the intercepted arc is twice the measure of the inscribed angle. Can't get much easier than that. So 2 times 70 is 140, okay? Now what's the length of arc EABF, all right? Well, it's 140 360ths of the circumference, okay? All right, so that's how you would find the answers for those 3 questions on your semester test, all right? Now, there is so much in Chapter 10 about equidistant chords and angles formed with tangents and radiuses and all those other kind of things that I would love to have tested those. And had we been here, we would have done a lot more of those. But I picked these 3. I mean, I consider this to be the absolute basics. All right? In fact, I feel kind of guilty that we're not doing more. But that's where we're at. Okay. So digest those. That should help you out on those 3 questions. I give you the page numbers to look at, to reference, to help you find solutions to those as you work through those. So that's what I got on this one. And the next one I'll put up is some surface area and some volume of some kind of a polygonal pyramid. How's that? All right. Until next, Mays out.